For you.
And we're recording whenever you're ready.
So, my name's Chris. I'm with a company called Vintality, and we're a precision agriculture kind of soil specialty company. And so what we've been doing with the team at Terroir, which has been super exciting, is investigating the soil on this really amazing site. And you're going to see some really it's a beautiful site, great aspect. And so we've been looking at what is the soil actually giving us? What is the terroir actually giving us at this site? How do we match that with varietal wine style, with the winemaker, with the team here? So that's what we're currently investigating with these soil pits. And we've got some really cool results to share with you.
Yeah. So 75, 150 is
centimeters.
Yeah.
Yeah. So the one thing too to say on the 150 centimeters is it takes the 75 and then adds another 75 centimeters.
Yep.
So if we have something really high up in the profile, then it will be captured in both.
Yep.
Like if there was like a body of water sitting here, it would be high in both, even though it's shallow.
Yep.
Because it adds up both. So what we're looking at right now here is these are electrical conductivity maps. This is what we call EC, and what it's measuring is how the soil down to 150 centimeters, 1.5 meters, is conducting electricity. And that might sound kind of crazy, but what that's measuring is what is the soil texture in that area, how much water is available. Because if you think about what conducts electricity, well, again, you know, if you've ever been in a lake when there's a thunderstorm, water conducts electricity very well. Air, conversely, does not conduct electricity well. Well, what else does is really fine textured soil. So if you think of a clay, what clay is these stacked soil layers really tightly with these ions in between, or even a little less, but still fairly high, is a silt. So silt is a very fine soil. You grab it and feel it, and it just kind of disappears into this really fine texture. That's like going to give us a high. On the other side, on the low side, which is going to give us a low, what doesn't conduct electricity, is going to be really coarse soil. So a sand. So think of a really large sand that has lots of air in between it. So again, that doesn't conduct electricity well. So in where we are in the Okanagan here, that's if you get into what's called the black sage and Oliver and Osoyoos. So you have this very coarse sand, that's going to give us a low. As well, a lack of water. So we could have a site that maybe had a lot of clay, but for some reason was super dry all the time. Well, that'll then kind of muddy the picture a little bit. And that's why we dig these pits. We get these results and we'll look at them in a bit more detail. And then we investigate what is driving these results.
Amazing. So we're in this corner. I thought the one thing that was interesting about this corner is like at the high bar, there's just like this one bullseye, but then it like kind of disappears.
So probably what that is, especially because it's shallow, is probably just something human.
Yeah.
So we get that a little bit. I didn't remove it just in case.
Yeah.
But often we'll edit it out because you'll have like metal plates or something you'll drive over.
I understand.
Pick that up. Yeah.
And then I'll pick it up.
Yeah. So what's interesting about this site too is we're low at both depths. And one of the things we see, and we're going to compare this to other sites, is if we look at the soil, it's both fairly dry, and we're going to see some soil that's a lot wetter, but also as we break it up, it's quite finely textured. So this I would call kind of a very similar, kind of within the standard profile of a Naramata silt. It's kind of what I expect. It's a very silty soil. There's obviously a little bit of sand. It's fine, not insanely fine, but also we have little bits of rocks mixed in. And obviously you can see here within the profile, we have tons of stones and rocks all throughout.
Mind your business.
There we go. This is cool. So this section, I mean, I imagine this will just this also will influence how we water,
100%.
How much water we add.
Yes.
I think for us, like one of the things, it's historically, like these pits would also influence which rootstock you use.
Yep.
So whether you want to use like a drought resistant rootstock or a vigor resistant rootstock, or that would definitely influence our planting program. Yep. I mean, you and I go back and forth all the time on this. Unfortunately, I think the freeze of 2024 has drastically changed my opinion of viticulture. I find it too risky in a site like this where I can't hill up not to own root vines. Yep. So we've gone with the idea of own rooting vines, but we have different clonal, we have the ability to use different clones and different properties that are, some, especially with all the Pinot Noir we're planting, I think in soils where there is higher moisture, so where we're getting highs, we potentially will use, smaller buried clusters that have a slower uptake of water, so we can fight, botrytis or potential disease that way. So all of these all of this mapping and all of this soil, like especially digging down, digging deep, I think really influences, the viticultural future of this site.
Well, I think you talked about something else too. We were just chatting about is also the aspect, right?
Yeah.
Like there are other factors you were looking at other than just what we're seeing. Like the soil's a huge part of it, but it's not the entire story, and so it's matching it up with also what you want to do stylistically, quality-wise.
For sure.
Right, and that's a lot of what we're then we work together to. You're going to as a team matching up with what's going to get you the most interesting fruit, the coolest wine that you really want to make.
Yeah, and I think it's like so fun. Like, I feel like the opportunity on this property to, showcase different clones, and different like the Pinots we can produce off this property just from like, one block to the other block is huge because you don't often get like 12-acre vineyards in North Naramata that have all these different soil profiles. A lot of the larger vineyards, and correct me if I'm wrong, but like Black Sage sand is Black Sage sand. Yeah. You tend to get these bigger deposits. Seacrest Mountain Vineyard, another one of our vineyards, like we will eventually do this down there. It's in the process, whether it's next year or the year after, but this will be happening down at Seacrest. We'll do the exact same process. We'll EC the whole property. We'll get a template. I imagine we'll find less diversity. I think you just tend to have more consistency, whereas like all of these rolling hills and all these deposits in Naramata tend to be quite unique to the specific space.
It's the glaciation, right? We're in an area in Naramata where there was just tons of mixing. So that's where we get there's a site down there that you guys are familiar with. Obviously, that's sand, right? We have a little pocket of sand, and we see that throughout Naramata, where even above and below the road is traditionally, but not always, a delineation.
I've heard of it. It's a pretty big delineation, right? Yeah.
But it's sometimes surprising. Like we were working with Scott Smith at another vineyard there, and it was like what was supposed to be in that cut all of a sudden showed up a whole stretch down below.
Crazy.
When we did it, which was unexpected. So it's. A lot of people don't realize we have internationally unique soils in the Okanagan here. Like these are not, we can get into all kinds of technical stuff, high pH, there's a bunch of but from that glaciation, these are soils that we don't really have anywhere else, at least in the wine growing world, that are like this.
And I think it shows. I mean, unfortunately 2024 was hard on us, especially on this property. Well, obviously it got rocked because there's no vines left. But again, I think like when we talk BJ with you and Alistair and ownership, through this like negativity, there's also the opportunity for something brand new and something fresh, and like the opportunity to really like put our stamp on Schwa's identity and where we want to be 15, 20 years from now. So I think that's one thing that's really interesting about doing this work, doing the soil pitting, really getting to know our site. We have like big plans for this vineyard, and to hear this, and as we're digging deep to see that we have all this diversity in these different layers, I think just proves that we've picked a spot that has a really bright future. Yeah.
Make some beautiful wine.
Yeah. So this is kind of a interesting part of this property. We kind of have the main 10 acres, I would say, on the slope, up high, separated. But there's this kind of bottom corner. This used to be Pinot Gris. This is where the Jack's Pinot Gris came from, that we made, was from this one corner, and it was so much different than everywhere else because you've kind of like passed through obviously a riparian zone, like a big change, and I always thought that the soil here the fruit felt riper and bigger and it had a little bit more depth, and because we had Pinot Gris in that top corner, which was like apricots and citrus and bright and high toned, whereas down here fruit I found coming off of it tend to be more like riper, broader in flavor profile, a little bit richer on the palate as well. So, and like, tell me about the maps, because this is the one area of all of our mapping. So we're in this bottom corner down here that at height were low and at depth were pretty high.
Yes.
So I thought when I first saw these maps, you see a lot more consistency in the other areas, whereas this is kind of like, wait a minute.
You're spot on, and that's one of the things we look at right away is like, where do we see variation at different depths? Because that tells us we're going to see something unusual. And so we are at the lowest point, the driest part, the sandiest part is kind of what we would expect of the vineyard is here, shallow, but then at depth we're moderate. And because this is so low, what this tells me, this actually is probably a little bit higher at depth, and that then fits. Because then as soon as we go down, like once we're down, let's say about 60 centimeters, look how moist that is.
Unbelievable.
That's insane.
And so this is where
no water has been on this property in
And it's even
Other
like
than
just,
natural
it's
rain,
loamier too.
Yeah.
Like it's not just a presence of water. Like this is a soil that is a lot more loam.
It shapes when you touch it.
Yeah. And it's just that
So
you can smell, it smells earthier, right?
It's
yeah.
more organic material than that.
So just for like layman's terms, loam is a combination of sand and
So
clay.
loam is kind of more sitting in the middle. So we kind of call it this. We have the soil triangle,
Yeah.
which we have clay, silt, sand at each point.
Yeah.
Loam is just kind of the soil that's sitting more in the middle, more towards silt and clay. So we're kind of
Yeah.
moving more towards clay, but we're not at the point where we would actually call it clay. We're kind of moving in that direction, either kind of from the sandy or the siltier side. So we're kind of more in the middle towards clay in terms of what we're expecting in terms of structure. And loam for layman is kind of like what you're seeing when we're talking about loam. We're talking about soil that you maybe normally think of in your garden. Loam smells really earthy. Again, traditionally there's always variation, but especially when it's wet, it's kind of more that traditional growing material.
For sure.
And there's actually a limit. Like this is not a bad soil at all, but it's a little bit, you typically have a bit more fertility with loam. And that's why, like when you go to the Midwest, say of the US or the prairies, it's not a good place for grapes because it's too fertile.
Yeah, and that's why it's like ground crops, corn.
Yes.
Everything. Yeah.
Exactly. We want the stress. We want the sandier, the siltier soil, the gravelier soil. Those are where, not just here, but around the world. That's, as you guys know, that's where we get the better crop. We get
Absolutely.
better wine.
So silt, for example, like this is like deviating away from this property.
Yes.
But like the Skaha bench,
Yep.
like where.
And they're siltier. Like this
Yeah.
is silty for sure.
Yeah. I always find at those properties on Skaha, is like when you walk through Convita Vineyard, I always call it moon dust.
Yep.
You like take a step and you know if there's no wind or rain and you go back the next day, you could like trace your steps right away. Is that height, would you consider that like pure silt? Like really, really high silt or?
It can be. It can vary a little bit because you're kind of moving, because we're kind of thinking of it as a triangle.
Yeah.
It's not like a line where we're moving. I mean, you kind of are moving from like really coarse sand to fine silt. And then when it gets fine enough, it forms these layers and we now have clay.
Yes.
But really, it's a bit more of a triangle. So you're kind of sitting somewhere probably in there with that fine silt. The question is, where is it moving? Is it moving maybe? I would expect a bit more sand. There's not many. Kelowna has some real clay. Like we've done work in Kelowna where actually you have like, you could do pottery out of this.
Yeah.
Right? It gets so thick.
Yeah.
But so probably it sounds like a really fine silt, especially as it dries.
Yeah, for sure.
But one of the challenges we see with silt here is kind of what we call this drying effect, where you can kind of see, so this is a silty sand, and we'll kind of do some more work and figure out what exactly, but you can see as it dries, that's where it's from the silt really that we get this hardness. Now the nice thing about this soil is we have a lot of rocks mixed in. We have even some fine gravels you won't be able to see on the camera, but obviously when we were feeling it, we can feel there's like little stones mixed in.
Yeah.
And I think partly that and just this quite ratio, it's hard, but it's not forming super compact. Like those soils we worry about are where I have to get a pickaxe out to get soil samples and stuff like this. So this is drying. This is a soil, especially in the heat of summer, we'll want to keep a little bit wetter.
For sure.
But this is what can happen with silt. But again,
There's
we can also
pathways
see,
for the plant.
Yes, exactly.
Yeah.
And you can see there's still, like because this pit's been open, it's dried out a bit. But we can still see
Wow.
there's still,
Look how much moisture is right behind
Yes.
there. Yeah, wild.
but it's super cool. You can see the drying effect because as soon as I feel this, that comes off.
It changes right away.
Right? So this is a perfect example of what happens with silt and structure is it dries out, it's hard, right? Again, there's not a compaction layer, but it's definitely getting harder. And there are silt soils we've seen at other properties where actually it does form becomes like a rock.
Yeah.
But here we can see we scraped that off and look how easy all of a sudden it comes off.
Yeah.
But also we have a really nice soil variation here as well. So one of my questions is, this area may not have actually had that much soil moved on it.
For sure. This could be potentially like an original deposit from the glacier.
And that's where we're looking at this. And again, I don't know how well it's going to show up in the camera, but for you guys here, we have a really clear line right here, a soil color, right? So that's showing to me, okay, we definitely have a clear delineation. But what's also so interesting is the fact that this top layer is so low in EC.
Yeah.
It's fascinating to me. Like I would have expected, this is still decently silty. I would have expected, a sandier, coarser soil.
Yeah.
But what this tells me is that shallow, we're not seeing much water, which is super interesting. But then what that is really suggesting to me is a lot of the water that's
It's getting
here
sucked up by those.
is getting sucked up by those, and maybe again there's deeper water that is rising a little bit, like maybe some of that moisture.
For sure.
Or it's just the soil texture. We just have a loamier soil, it holds more water.
Yeah.
But this upper layer gets super dry.
Interesting.
It's very neat.
That's so cool, man.
It's so cool.
It's interesting. You see, like, do you call it stratification?
Yep.
Is that what like the
Yeah,
line?
that clearly stratified layers, yeah.
Yeah, interesting. Which you would figure would make sense if it hadn't been manipulated by equipment.
Yep, exactly.
Whereas if you did, when you are pushing big amounts of earth,
Yep.
it just becomes a conglomerate.
Yes.
Right, and then you just get like big, huge, 1 foot, 2 foot, 3 foot depths of like consistency. Whereas right now we're seeing like, okay, it feels like this is like more a natural corner. I don't want to say natural, but more of an original, 10,000-year-old deposit.
Yeah. And I think that's one of the challenges. Like, you just sometimes have to move earth. You have no choice. You can't farm without it.
For sure.
But it's those effects. I think a lot of people think, oh, after 10, 20 years, it kind of goes away. It does a little bit, but the effect is permanent. Like, you permanently change the soil within our lifetimes and our grandchildren's lifetimes. You've changed the soil.
For sure.
And it's interesting. There's a special soil sampling technique we use. We call it bioavailability, but it's a much weaker, but we can't soil sample on a site if it's been bulldozed for 10 years because the results are, you have to throw them out the window.
Yeah.
Just because the soil is so affected that we can't get a good soil sample result.
Yeah. Okay, so I think really interesting. We've just moved, 100 meters?
Yeah,
Less
less than that.
and we're coming across, we're talking about more silt. Like, you can just look at the pile over here, dark earth. These piles have been sitting exposed to the sun for the exact same time. These pits were probably dug 15, 20 minutes apart. And you just walk over here and we have this like, what do we call it? I don't know. This is like gravelly.
Yeah, it's silt and gravel. It's
Silt and gravel, and a lot less of that like earthy aromatic. And I think when we come to, again, this is why it's so fun to do the soil mapping, is we can see where at depth our heat tracing, our highs, so our high conductivity is starting to come in, and you can see how it pushes through this bottom corner, right? So the first pit was in this low, and then like a moderate low, you would say, with green.
Yeah.
And then you can see the high just kind of creeping in at shallow, and then at depth, which means we have like at 150 centimeters, something else, this layer of high conductivity kind of pushing through the soil.
Yes.
At such a close distance, right? Which is interesting. And I also think you said something earlier, how we often, like, farmers have used Naramata Road, this road here, as a soil delineation, because as soon as you cross, the amount of rocks disappears, right? Like, it just becomes a lot more purity of silt, clay, sand.
Normally, yes, exactly.
Yeah.
Yeah, exactly. Yeah, and I think what this kind of speaks to too is, we were talking about the first case where we had the change from high to low, from the high EC, the low to the high EC.
Yeah.
This again is just confirming that we are obviously in a transition zone through here.
Yeah.
And it kind of fits everything. It's the riparian area. It's like we are in this different area. But even looking at, like, this is kind of what silt does, is it forms, we call these PEDs. So this is not rock, it's a soil, it's silty soil. And as it dries, especially, or gets naturally compacted, it kind of forms into these structures, which you can break apart. Again, it's just dirt,
It looks like a rock.
but it looks like a rock.
What'd you call those?
PEDs, like
PEDs.
PEDS.
Interesting.
Yeah.
I learned a new word today.
And as you break it, you can just kind of see, like, it's
so light.
yeah, with some, again, gravel, a bit of gravel mixed in.
Yeah.
Little gravels there as well. And so that's where, again, we're seeing, like, even here, and Rich was talking about this, is it's drier, but look at the color difference. So again, I don't know if it shows up on camera, but we have this upper layer is a different color than the last pit, but also it's dried out just as much as the other one, but look how much less compacted it is.
Yeah. Do you need your spoon?
No, here we go, my spoon.
Your soil spoon.
Trowel.
Trowel.
Yeah, okay,
And then
and shallow, okay, here, feel this, Rich.
Yeah, it's so moist. Yeah, wild.
Thank you.
And compare that, again, that upper layer. So that's where we're starting to see this transition
Yeah.
from there, where this upper layer is very different than the last pit we did. where we've got a lot more moisture. It's obviously low. It's not as loamy as a deeper layer, but it's loamier, fluffier. It's actually really nice. Like I'd look at this and I would go, okay, this does not look like there's any bulldozing movement that happened here.
Yeah.
Can't guarantee it, but that's definitely what it looks like.
Well, and there's like more moisture at a higher level here. Like we had to go a lot deeper to get to the moisture in the last pit.
Yeah.
Whereas here we're getting a lot more moisture. And could that just also be, I mean, more water's available at the bottom of this hill.
Yep.
The trees are taking up more towards the top, and as the moisture and water flows down, we're settling a little bit, because we do tend to flatten out a little. Like we lose some of the steepness of our aspect here as well.
You're completely correct. And the other interesting thing is this is actually a different soil down here than we had. So even the deeper soil over there was loamier. Well, here we definitely have moisture.
Yeah.
But it's a different color. So the loamier soil, you feel that, like that depth. Yeah. To your point, is less the soil texture. So I would say the last pit is holding on to some of that water because it's a loamier soil, which naturally will have a higher water holding. It'll hold on to more water naturally.
Yeah.
This soil normally would hold on to less, but I think to your point, there's more water here.
Yeah. That's
coming downhill. So this is part of why, again, these pits are so cool, because there's a natural variation. Because you can kind of see this is harder down here. We're again more into that drier silt that we're going to see in some other areas.
Yeah. I feel like it's like, also it's just like, shows the importance of getting roots deep.
Yeah.
And doing everything in our power to like drive growth down, rather than, like you see a lot less, like remember when we're on the slope up high, we were getting like roots starting to come through at, at 2.5, 3 feet. Whereas here, like the moisture availability kind of towards the surface, which we're noticing in this heat map, we tend to see most of our root mass at a higher level, because it doesn't need to go, it doesn't need to go down.
Yes.
Which I think will affect how we water. And like you're saying, water's pooling here, water's collecting here. Yeah. Like we stick a moisture probe down here, I think we're going to get a lot of interesting readings.
Yeah. I think that's completely, we're stopping at, let's say, roughly 50 centimeters here of root growth. Yeah.
And then there's nothing. Whereas like in those other pits, I mean, we had some pretty strong tap roots coming out at, at the bottom of the...
at least 100 centimeters.
Yeah. Wild.
Means we can be more sustainable with our watering program.
Yep. That. So now we're in that high, that EC high that we see running down. And look at this.
It's like standing water. So if we look at, again, the maps, going back to the maps, 75 centimeters, 150 centimeters. We have this one huge high right here. So at depth, it's really high. And then at surface, it's right. And when you look in here, I mean, we're standing in water. We have like standing water in the bottom of the pit. This is the only one that's shown this much moisture by far.
Oh, yeah. And the thing that's super interesting is this is clearly, this is a underground aquifer of some sort, because just looking at, feeling this soil, this is super sandy. Yeah. Like this is with some gravel mixed in, like this just really feels.
Do you think this is man-made?
I don't think so.
This would just be a natural...
I think this is just, if you want to just feel how sandy, like this is the coarsest...
This is coarse sand.
Yes.
This feels like what we put into our...
Mixed with gravels.
Our sand filters down at Seacrest for the
Yep.
water. Yeah.
And then again, we also, no, this is not man-made, this is natural.
This is
I mean, well, I should be careful. Part of what could have happened is you could have had one of the things we've seen with sometimes is when you bulldoze and you don't know that there's underground water, you can then create a massive water moving in really unexpected ways in areas.
Is this the hard pan you're talking about right here?
No, this isn't even a hard pan. This is, feel this is clay.
This is clay.
Again, this is not a true, like this is a sandy clay, like this is not a true...
Red clay or black clay.
Yeah, exactly. But, like just feel that.
Crazy.
Oh, wow.
Yeah, and this is, again, traditionally what we see when we have a water system, a creek or, something like that. We'll kind of see these kind of layers. And so we're probably kind of closer to the top of it. And again, it may also have been disturbed. So kind of the original path maybe has been changed, or
with the bulldozer on the top of the hill.
Yeah, or just someone even further up above. Then maybe this was actually more water was moving through here 50 years ago, whenever. And then kind of maybe even someone further uphill, like another property or just work they did here, has changed it a bit. But
could you think that potentially as well, because this has like coarser sands, that maybe just from irrigating the top of the hill, like over the years of irrigation, water's just maybe collecting here? No, this is...
No, the amount of water you would have to do that would be you wouldn't have an overhead system. You would have like a massive pump just pumping water to get this. Like for example, like we have a client right now that there's a creek moving through, and they have had a drainage pump with a pipe about that size has been pumping water all winter out of their property.
Wild.
Just coming out nonstop, still coming out like nonstop. And you just think of that amount of water, like there's no amount of irrigation you can put on that will come anywhere close to this. This is water's coming through, and this is then where like, once these plants get established, like we don't
even need to water.
No. Because you're going to have the opposite. You have the vigor problem. And this is where it gets really interesting with you as a winemaker. Is it's also like, okay, you're going to have a Sauv Blanc here. Like,
Sauv Blanc's so vigorous.
Yeah. And what do you want? Quality parameter? Like, what do you want?
Definitely going for quality off the property everywhere.
Yeah. So then, like, how do you then kind of like, this is part of the question is how do you match that up with this area, which is even different than just the last pit we did?
For sure. We could put an infinity pool here for a hot spring.
Richie's pit.
Yeah.
Also, super interesting. Look at the roots.
They're deep.
But look where they stop.
Yeah. Right before the sand?
Yeah, they're kind of stopping right. It seems to me.
They hit it.
Yeah, they're kind of hitting this.
Yeah.
And I think there's
there's one.
Like there's still, but this is where, again, as soon as you start to see like a really fat root down here, that always is a sign to me.
You call that a tap root?
Yeah, you could call that.
It's moving horizontal, not down.
Yeah.
So is that because there's more moisture in this silt clay pack? And
yeah. So it could be a couple things happening. It could be it doesn't need, but the fact that it's moving horizontal is always interesting to me. What that suggests then is it may be too much moisture. It's probably getting waterlogged.
Yeah. So, it's like
that fat at that depth.
Yeah.
That's pretty intense.
Yeah. And so probably part of what's happening.
Is that like granite maybe?
I don't think so. It's hard to say. This might be nice. Looks like a metamorphic.
Yeah, Chris, do you see this one?
Oh, cool.
Same but different. So
Yeah.
Slatey, right?
Yeah.
I don't think do we have slate in BC?
Ooh, okay. This is okay. This is cool.
Yeah.
Okay, so,
There's another one.
yeah, this is what we call alterite. And this is always a really cool sign. So what alterite is, now this is a metamorphic. You can see, hopefully on the camera there, but there's really cool layers. It almost looks like, it's a rock, but almost has like clay type layer striations through here. So it's a sedimentary rock that has been kind of compacted. But what alterite is and why we love it around the world for winemaking is it's a decomposing rock. So what that means is the rock, through often chemical or physical weathering, is starting to collapse. And I am not that strong to be able to move to break up a rock like this.
So that's like carbon, organic matter type stuff?
That's that, but it's also just a sign that the soil's been sitting here for a while and you're starting to see kind of things break down. And just around the world, like they love this in France when they find this. So like, it's just a cool sign when you see something like this. The winemaker's happy. When you see stuff like this, that's
Would
soil.
you say it's typical to Grand Cru vineyards in Burgundy?
Oh, this is 100% Grand Cru. Like definitively unquestioned. Put it on the label.
Let's go.
You won't get sued.
Richard's
Love
happy.
it.
Yeah. But what this means is that you have a lot of weathering in here, which means you're going to have something really, it's going to be more interesting. Now, it's complicated because...
How do we mitigate? We can't mitigate the moisture, can we?
No. You could put in your drainage tile.
We could probably put in drainage tile here.
Yeah. And then it's like managing, but also knowing obviously young plants are going to be different, but when they get down here, it's really, yeah.
Well, we could like come down and distribute it into this riparian
zone.
zone.
Again, I think your neighbor
Straight down into the neighbor.
Yes, straight down into the neighbor.
I love that you
That's
say
their
that.
problem now.
Cut it out.
Maybe his best friend.
Cut it out.
Good fences make good neighbors.
What is it? And this big one, there's a lot of color in this one.
Yeah.
That's the whatever you were just talking about, but just younger maybe? Because that doesn't flake off. That's just more of a... No, I have. Yeah, it's interesting.
It's so cool, hey?
That's just kind of... I just pulled that out of the rock wall, and this is kind of...
Yeah. Okay. This is a cool. I actually don't know off the top of my head. Again,
a lot
this
of color
looks.
in this.
It's beautiful.
Look at the black layers.
Yeah. Wish I left my do you mind passing my pick?
Of course.
That's exactly what this is for. So I actually, off the top of my head, I have to do some thinking. Thank you very much. What?
So I just pulled that out of that gap right there, and it looks like it's just going through it.
I just watch. So Yeah, look at it.
Beautiful.
Yeah, look at that.
Stunning.
So we have obviously lots of, so what a lot of the shiny is mineralization. So we have lots of mineralization. And again, the fact it's breaking apart probably also helped by the fact there's so much water here.
Yeah. Oh, so it's decomposing.
And this is so you have different stages of alterite. So you have some alterite that is effectively soil. You'll find rocks and they're almost soil. So it's rocks turning into soil. So we have different stages just beginning to almost soil. So this is kind of in the middle, but this is but that's where some of the minerals in the soil. And people think that vines, you can't taste rock.
Yeah.
Like this is a silly idea that if you ever try licking a rock, it doesn't taste like you don't have wine. It may be colorful and fun to talk about. Obviously, it doesn't actually taste like slate because slate literally does not have a taste.
Yeah.
It never does. If you lick a rock, you're only tasting bacteria or other fungus.
Minerals, right?
Yes. Well, minerals don't, you're not going to get. You don't have the capacity to taste. What you're tasting is living things on the rock. But what does happen is this does break down into nutrients and minerals and stuff like that.
Yeah, and then the soil can potentially uptake those.
Exactly.
Yeah.
And that's where you then start to get some of this variability in different soil types or geologies. So this is super cool. I actually have not seen a stone like this in a vineyard here in the Okanagan. So yeah, I'm going to take some of this home with me because
Feel free to take that one with you.
yeah.
Well, it kind of looks like it even keeps going. Like there might just be, but look, it's a pretty big piece. Right?
Oh yeah, look at that.
There's a bunch more here.
Here. And look at
just keeps going.
but look how
Like you say, it's decomposing stone.
Yes.
That's pretty cool. I wish it was fucking gold or diamonds, but whatever.
Gold in the winemaking world.
Crazy. Could that also be I guess the formation of our geology in the Okanagan is quite unique, right?
Yes.
Due to the fact that it's glacial till. And like you say, sometimes there's just pockets are deposited.
yes.
So this could just be this one high tone zone.
Yep.
Could just be some of this, different style of rock, different style of stone, different mineral deposit that was just plopped down here.
Yeah.
And just along with the fact that water's obviously pooling here, there's an aquifer, it just, these two variables come together to produce something different.
Yep. So one of the things we commonly see in most areas here in the South Okanagan is our soils are very high pH, and that's almost always due to calcium carbonate. So what that is it's a formation of calcium that gives us a very naturally high pH soil. Most wine regions are low pH. Champagne, for example, is a high pH soil. It is calcium carbonate, in its case, limestone.
Yeah.
We actually don't have lime. There technically is a couple places, but not really. We have no limestone here. The calcium carbonate is a byproduct of glaciation in different geological provenance. So it's actually not limestone, but it is kind of similar in terms of some of its characteristics. So what we like to test for, to see kind of how just in the field high pH, we take some acid, this is just a muriatic acid, you get at a pool store, and we spray it on to see if we get a reaction.
Yeah.
And that is a very strong reaction. What that immediately tells me, this is a very high pH soil.
Yeah.
And so we'll use it to test the different layers. So even this kind of clay layer, that is a super strong reaction we're getting.
Yeah. We've soil sampled everywhere, a bunch of places, and we've got some high pHs. OK Falls, we have 8.4 in some spots. So yeah, it's something that we're getting very used to seeing those high level of reactions.
So one of the other, and it's going to be actually the pH here is so high it's going to be difficult. So one of the things we also see.
You want to try on one of these rocks?
So why do we'll often see roots here. Sometimes we think that actually they may be hunting calcium carbonate.
Yeah.
So roots sometimes seem to like it, but also you might have water pooling. So one of the questions is.
Smaller reaction down there.
Yeah.
Oh, compared to the other side. So the calcium carbonate's building up on the bottom of the rock.
Yes, which suggests to us that and you can actually sometimes feel it. So this is actually a way to test, has this area been bulldozed? And so I'll go back and do this through when I do more of, do you have a brush in there?
Yes, we do.
Thank you very much. So we'll clean it off. And so what happens naturally is a way to tell actually if this rock has been moved, typically. Because what we'll see is if this rock is, say, sitting here in the soil profile over thousands of years, calcium if we have a high calcium soil, it'll bubble up and then stick to the bottom of the rock and evaporate from the top. So if it hasn't been moved, and you can actually often feel it, this doesn't feel.
Oh, it's visual. It doesn't really look like it.
No.
Do you know where it's like the Black Sage gravel bed, like where Bartier is?
Yeah.
And Riverstone, when you pick up a rock in their soil, you just flip it upside down and it's white.
Yes.
And every rock is white on the bottom and like normal color on the top.
Yes.
So it's quite interesting. Yeah.
And you're describing exactly it. We call it kind of like calcium nodules or whatever. You can really feel it. And so that's what it looks like. And it probably was sitting like this, right?
Yes.
Yeah, it would have been. So what this suggests is at least where this rock came from, because if we drop it again, we're not seeing a reaction on.
No. But then a huge reaction on the bottom. And you can see the white nodules,
Yeah,
right?
like you can
see the buildup there.
Yes, you can feel it. It
Yeah.
feels, it has like a specific feeling to it.
Look at any shower head in Naramata.
Yeah.
Like,
So, I mean, that's cool. That again suggests, interestingly, there seems to be less, if any, movement here, which is cool. This is the WTF of soil pits.
yeah. This is this is the WTF.
Yes.
Okay.
So right there we have sand, coarse sand. You go feel it. We're like right beside it.
Yeah.
This is but the weird thing is we get a bit of an EC high here. Not the highest on the property. Obviously that's the water pit, but this is really high. Yet it's kind of sandy. You look at this, again, it's a finer textured sand, some silt mixed in, but it's pretty, like I'll grab you down here, Rich, like just feel that. Tell them what it feels like.
Yeah, it's like clay, like silty loam, like sand. It's
like
so fine.
Silty
It's
sand,
so
yes,
fine.
very fine.
There's no small rocks.
Yeah.
Beautiful.
There's no grit to it at all.
But we see modeling. So if you can get the camera around here, see this orange?
Yeah.
All throughout.
Oh, wow.
So this has a water issue.
It's
Holding on to too much water.
yeah.
It's likely, my guess, and again, let me do some more thinking, but my guess is that this is below here, once we get this soil change,
Yeah.
is that we're getting, I'll move out of the way so it shows up, but what we're getting is it's getting waterlogged, is my guess.
Yeah.
So
It makes a lot of sense. So like where Eric always talked about the moisture was like just down here.
Yeah.
Just like standing water.
Yeah. And so this is a sign of why is this area struggling. Again, the thing is on the face, this is why the soil pits are so cool, is on the face of it, you look and feel the soil and you're like, yeah, it's great. It's kind of a silty sand, sandy silt.
Yeah.
You know, it's finely textured, but great, you're gonna have a great root exploration. You know, again, like this is
It's not hard panny, is it?
oh, not at all.
No.
No, you can, this is sandy.
Yeah.
Again, a finer sand with some silt. Like it's a very finely textured sand.
In the
but-
triangle, we're kind of like closer to silt, but on the sand side, further
Exactly.
away from the clay side.
Correct.
Yeah.
Exactly. And so, but the fact that all of a sudden we see this orange, we're like, okay, there's something that's not working in the soil to generate that. And so that's where, again, it's completely unexpected, but we're seeing something here and it's like, why was this area struggling? Well, it has water issues.
Yeah.
But the opposite of what you would expect. You
Yeah.
would not expect this in this soil.
Yeah. So when you think about that, like when you think about how different this pit looks from everywhere else,
Yes.
is this just another freak deposit from glaciation?
Yep.
This doesn't look like it's been pushed here.
No.
This looks like it was dropped here.
And the reason too, I think you're exactly correct. And also it's like, where would this have come, if they'd pushed it here, where would this have come from? Because what they would have been pushing
Is what we
is the
see.
silt
Yeah, is the silt.
and the rocks. We'd see stones and rocks mixed in here and stuff like
But
that.
we just have like even if you look at the pit, it's just like all fine sand, like you
Yes.
said, right? Like it just crumbles to dust.
Yeah. Yeah.
So moisture, I wonder why it's building up here. You think it would just flow right into nickel?
Yeah. And traditionally with sand, like there are actually examples I've seen of sand, even coarser sand than this, where this happens, but you shouldn't see this kind of modeling without a lot of somehow water standing. Like it's not a matter of it being over irrigated, or it's very unlikely that it's water coming from above. That's where you think like there has to be probably water coming from somewhere else.
From below.
Yeah, exactly.